Hi students, welcome to the world of tricks. Today I am going to take solvent topic, and from solvent I will convey you three concepts with tricks. So starting with solvents, we know solvents are medium. Okay, medium for what? For reaction. For a reaction, solvents are used as medium. Okay, solvents may be liquid, gas or solid. We mainly use liquid solvents for our reactions. Okay. Why we use solvents in a reaction? Let us take a reaction. A reactant in the presence of any reagent, maybe it is a nucleophile or electrophile, we will get a product. Okay, and here we are adding medium as solvent. Okay, medium as solvent. For the further concept, you have to keep in mind a common rule in solvents that like dissolves like. Like dissolves like. Okay, I will explain it later, so don't worry about it. Okay, suppose in a reaction, solvent may act as non-participatory as well as participatory. What this means, the solvent do not interfere in the reaction, while the solvent solvating, or you have to consider as dissolving the reactant in reagent, or reactant and reagent are just dissolved in the solvent. So this is a little bit of information regarding solvents. Moving on, the first trick, the solvents are classified into two, namely polar molecules and non-polar molecules. Okay, we have to differentiate it first. Okay, the trick for differentiating these two are, from the name itself we get the informations. Okay, so first of all, the first differentiate between polar molecules and non-polar molecule is, from the name you just pick up the last three words. Okay, last three letters. Okay, lar means large. Okay, you have to consider it as large. Okay, the first two letter is po. You can see this point where dipole moment. Okay, dipole moment. Okay, dipole moment. That means dipole moment is large for polar molecules, whereas in the case of non-polar molecules, the name, the prefix for the polar is non. Non means no. Okay, no large dipole moment. That means it implies what? It has small or zero dipole moment. Okay, what? Small or zero dipole moment. Are you understanding, students? Okay, now the second property is, for the second property you have to consider the lar. Okay, lar for large. The first letter in dipole moment is D, so the next property begins with also D, which is dielectric constant. So for polar molecules, dielectric constant is also large. At the same time, non-polar molecules, the dielectric constant will be small. Okay, small dielectric constant. Okay, dielectric constant. In the case of polar molecule, that is third point. Okay, it is the electronegativity difference. Okay, what? Electronegativity difference. Molecules means atoms. Okay, electronegativity difference between the atom is what? Between atom is same large. Okay, what? The electronegativity difference between atoms are large, whereas in the non-polar molecules it is small or similar. Okay, small or similar electronegativity difference between the atoms. So hope that you can understand this well, and you can learn it very easily, and you can don't memorize it. What is polar molecules, what is non-polar, what is its definition. Okay, so you can identify a molecule is whether polar or non-polar. Okay, now we have to, the trick is not completed yet. Okay, you have, don't worry, it will little bit is there. further. Okay, for that you have to remember that polar molecule is again divided into two. Okay, polar molecule is again divided into two, namely protic molecule. Okay, protic molecules and aprotic molecules. Okay, and aprotic molecules. Okay, what means protic? You can, from the name itself, you can identify that it is a proton. Okay, proton means what? It is a hydrogen. Okay, it is a hydrogen. From the name itself, we want to understand that hydrogen bonding is present. In protic molecules. Whereas here two hydrogen atoms are present. Okay, hydrogen atoms are present. But the hydrogen bonding is same name, A for absent. Okay, absent of proton. Don't not mean absent of proton, absent of hydrogen bonding. Proton means hydrogen, so hydrogen bonding. Don't get confused with that. Okay, hydrogen bonding. Okay, hydrogen bonding. Absence of, don't forget about that, absence of hydrogen bonding in, okay, absence of hydrogen bonding in aprotic molecules. From the name onwards we are getting it. Okay, so this is my first trick. So now onwards you are not going to forget it. You don't want to memorize the things. You just say the words and you get the answer from itself. Okay, and now it is the time for trick number 2. Here I am going to classify the molecules as protic molecules, aprotic molecules, and non-polar molecules. You know, protic molecules are polar, so polar protic molecules, and aprotic molecules are two polar. Okay, don't forget about it. Okay, polar protic molecules, polar aprotic molecules, and non-polar molecules. Okay, I am starting with non-polar molecules. As earlier I said that electronegativity difference between the atoms is very small or similar. I am starting with, this is pentane. Okay, what? Pentane. A pentane is a non-polar molecule. Why this is pentane? There are 5 carbon. Okay, 5 carbon, therefore pente, and this is an alkane, therefore pentane. Okay, now hexane. Okay, what? Hexane. I just added one more carbon. Okay, all these are carbon. Okay, all these are carbon, that is alkane. Alkanes are a part of non-polar molecules. Okay, all alkanes are not a part of non-polar molecules. Just consider these two. These two are, we are generally using as more. Okay, and now this is a 6 carbon, and I am drawing this 6 carbon as a closed ring. Okay, now this is cyclohexane. Okay, cyclohexane. If you got pentane, hexane, and the hexane is, now I draw like a cycle or a ring, and now next one is I am putting the same ring here and drawing the 3 double bond in it, that is a benzene ring is formed. Okay, a benzene ring is formed. So a benzene is also a non-polar molecule. Okay, now what I am doing is putting a benzene ring and I just put a CH3 to it. This is a toluene. This is also a non-polar molecule. Okay, there is no space. I am taking a new one. I told you up to toluene. Many other non-polar molecules are also there. So continuing, toluene is there, and now I am drawing the same benzene ring and giving 2 chlorine. You may doubt that since chlorine is an electronegative element and carbon is also an electronegative element, the difference between these two electronegative elements is much greater than those we discussed earlier. So how this is possible to a polar molecule? You just see that this is a symmetrical, okay, this is a symmetrical molecule. What happens so that polarity is in this direction, also in opposite direction. So what happens is the two polar bond become cancelled out each other, okay. Therefore the dipole moment is 0 or very nil. Okay, so non-polar molecules include also para dichlorobenzene. Okay, but chlorobenzene or metachlorobenzene or orthodichlorobenzene or metadichlorobenzenes are not non-polar molecules. Those are polar molecules. Okay, I think your doubt is clear. Okay, if you have any doubt, please mention in the comment box. So what we are making here is making a pairs. Okay, making pairs of non-polar molecules. First this two, pentane and hexane, and then we made the cyclohexane and benzene, then toluene, or we can say cyclohexane, okay, benzene, toluene, a pair, and an exception we found is para dichlorobenzene. And now CHCl3 chloroform is a good non-polar solvent. Okay, chloroform is also a good non-polar solvent. Here is also Cl, carbon CH. We also founded CH3Cl. So think about that and make that CHCl3. Okay, it is also included in the non-polar molecule. And now the last one you have to remember is Et2O. What is Et2O? Diethyl ether. Diethyl ether. So you have to remember this two. Okay, this two. Okay, and how the structure is CH3 CH2O CH2 CH3. This is the diethyl ether. Okay, so make non-polar molecules as a pair to easily understand. First of all, pentane and hexane, and then cyclohexane. Making cyclohexane from the hexane as a making it as ring. Okay, then from cyclohexane to benzene, then benzene to toluene, making a CH3 attached to it. Then an exception found is a para dichlorobenzene. From the chlorine and the toluene, we found the CH3. From both of these, we took CHCl3 as. This is just a trick to remember in a continuous flow. Okay, CHCl3 which is a chloroform, and then Et2O diethyl ether. Here also we are making pairs, and now I am going to take polar protic molecules. Okay, first of all, we all know what is a protic molecule, a polar molecule which is included in polar protic molecule. Okay, and then ammonia. Okay, water, ammonia, make it as a pair. Okay, water, ammonia. If ammonia got, you can write at CH3NH2 amine. Okay, this is also a polar protic molecule. And then we are taking all groups. Okay, all means OH groups. Okay, first of all methanol, then ethanol, then propanol. Okay, propanol, and then tertiary butanol. Okay, tertiary butanol, making this up a pair. Okay, ethanol, methanol, propanol, and tertiary butanol. Okay,
Okay, this is the another set, and the other set is which include acid. Okay, formic acid which is HCOH. Okay, formic acid, acetic acid. Okay, acetic acid, CH3COH, carboxylic acid. Okay, all these included in the acid category, and these are also polar protic molecules. Okay, and you have to also remember CH2Cl2 is also a polar protic molecule. You can see that all these polar protic molecules have hydrogen bonding. What? Hydrogen bonding. Okay, all these polar protic molecules have hydrogen bonding. As we earlier said, protic molecules have hydrogen bonding. And now we have to study the polar aprotic molecules. Okay, for this you should first remember THF. What? THF, which is tetrahydrofuran. Okay, tetrahydrofuran. This is the structure. Okay, if you remember THF, then go to DMF. What? DMF, dimethyl formaldehyde. Okay, dimethyl formaldehyde. These two are methyl. And now THF, DMF. Okay, and starting with DMSO. Okay, what? DMSO, which has, okay, DMSO, yes, then double bond O. Okay, sulfur attached to double bond O. Okay, these two are methyl group, which is dimethyl sulfoxide. Okay, dimethyl sulfoxide. Okay, if you got this, then remember acetone. What? Acetone, which is simply oxygen bonded to carbon. Okay, the carbon is attached to methyl. Okay, acetone. Okay, then you have to remember MECN, which is acetone nitrile. What? Acetonitrile. Acetonitrile. And there is one more, ethyl acetate. Okay, friends, ethyl acetate. Ethyl acetate, which has a structure So these are the examples for polar aprotic molecules. Here the hydrogen bonding is absent. Okay, no hydrogen is directly attached to a electronegative group. Okay, how we pair up this? Okay, these are linked with each other. Okay, THF is ending with EF, so you can recollect it with DMF. Okay, and you have to remember the structure. Now the structure is going to similarities. Okay, then DMF is also linked with the DM. Okay, DM is starting with the same as DMF, therefore DMSO. Then you can check for the structure. Okay, the DMF structure is with the formaldehyde. Okay, there is a double bond O attached to carbon, which is linked to nitrogen and hydrogen. Here in DMSO, a sulfur is attached to a carbon, which is linked to two methyl group. In acetone, the carbon is directly linked to an oxygen group, which is again attached to a two methyl group. And from this name acetone, we can get the next one, acetone nitrile, which has a C-triple-N bond. Okay, from acetone nitrile we get the acetate. Which acetate? Ethyl acetate. Here too the carbon bond is bonded to oxygen. How many oxygen? One is two oxygen and one is double bond and other is single bond. Okay, I think you got analyzing, you can understand that here is no hydrogen bonding, that is absence of hydrogen bonding. Okay, absence of hydrogen bonding. One more thing I forgot to mention here, CCl4. Okay, CCl4 as a solvent, which is a non-polar molecule. You can remember it with CHCl3, chloroform. After chloroform you can write CCl4 as a pair. Okay, by the way, this portion is a little bit confusing one, because remembering a molecule as a polar or aprotic or non-polar is a little bit confusing one. Trust me, if you are by heart this trick, you can easily memorize which molecule is polar or aprotic or non-polar. Now it is your turn. Please repeat this portion continuously to by heart it thoroughly. Okay. So my second trick is completed, and moving on the third one. Trick number 3, it will not take much time. Okay, like dissolves like. It means polar molecules or polar solvent dissolves in only polar molecules. Sorry, here it is polar molecules. Okay, polar molecules dissolve only in polar solvent. Okay, polar solvent. Likewise, non-polar molecules dissolve in non-polar solvent. Okay, non-polar solvent. You have to remember this. Also, you have to keep in mind that polar protic molecules, okay, protic molecules always prefer SN1 reaction. Which SN1 reaction, whereas aprotic molecules, okay, aprotic molecules prefer SN2 reaction. Okay friends, polar protic molecules prefer SN1 reaction and aprotic molecules prefer SN2 reaction. Okay, if there is E2 or SN2 reactions are possible, then SN2 is predominant over E2. Okay, E2 means elimination reactions. Okay, and one more thing, the leveling solvent. Leveling solvent means what is meant by leveling solvent? You have to remember only one thing, well. Well means you have to remember well. Okay, well means what? Yeah. Well, okay, in well what present? Water. So leveling solvent will be what? Water. Okay, water is the. Why this so called is all strong acids. Okay, all strong acids completely react with water. Okay, completely react with whom? Water. Completely react with water. Okay, all strong acids completely react with water. Therefore, all strong acid in aqueous medium. Okay, in aqueous medium. Okay, in aqueous medium means water. Okay, in aqueous medium appear equally strong. Okay, this is the important word. Okay, appear equally strong. That is why water is called a leveling solvent. So here is the end. Solvents, trick number 1, differentiating polar and non-polar molecules, and differentiating protic and aprotic molecules, and trick number 2, the examples for polar protic molecules, polar aprotic molecules, and non-polar molecules, and trick number 3, what is the which dissolves in which. Okay, and protic molecules prefer which reactions, and why water is called a leveling solvent. Okay friends, hope you will enjoy it, you will learn it. Keep learning. Thank you for watching. If you like it, please share it. Thank you.